Your helmet seal releases with a hiss, and the pressurized air of the airlock rushes against your face. Relief should come first, but instead, a smell hits you immediately sharp and metallic, like a blowtorch passed inches from your skin. Your gloves, your suit, your tools all carry the exact same acrid trace, as if you'd spent 6 hours welding steel, instead of drifting through empty vacuum. Every astronaut who has ever opened the airlock after a spacewalk describes the exact same thing. The unmistakable smell of hot metal and gunpowder clinging to a suit that just spent hours in a vacuum, supposedly incapable of carrying any scent at all. That contradiction sits heavy in your chest as you strip off your gloves. Vacuum should mean silence for every sense, including smell. Yet the odor refuses to fade. Space itself holds almost nothing, a near-perfect vacuum, stretching for millions of kilometers between you and the nearest breathable atmosphere. Molecules capable of carrying scent require a medium air dense enough to catch particles and deliver them to a nose. Vacuum offers none of that: no oxygen, no nitrogen, no humidity, nothing to transport a single molecule of smell across the gap between object and nostril. Your training covered this fact, clearly drilled into every candidate long before their first mission. Smell simply cannot exist in the vacuum surrounding your spacecraft, and yet your nose insists otherwise. The instant pressurized air floods back into the cabin. Oxygen atoms clinging to the exterior of your suit react instantly with the airlock's fresh oxygen molecules, forming ozone in a burst of chemistry too fast to see. That reaction produces a sour metallic tang, identical to the air right after a lightning strike splits open a summer sky. Somewhere in that same instant, ancient carbon compounds baked into space dust ignite chemically against your gloves, releasing a scent closer to charred steak left too long on a grill. Nothing about this smell originates from fire, smoke, or flame anywhere near your body during the spacewalk itself. Every source of that odor formed through chemistry alone, molecules reacting the moment they encountered breathable air again inside your pressurized airlock. Polycyclic aromatic hydrocarbons compounds, forged in the violent death throes of dying stars, drift silently through the solar system for unimaginable stretches of time. These molecules eventually attach themselves to spacecraft hulls, solar panels, and the outer layers of your suit's fabric. Nobody planned this contamination, and nobody could prevent it, since dust this fine settles across nearly every surface exposed to open space. Your suit absorbed trace amounts during 6 hours of exposure, holding on to them the way fabric on Earth holds the smell of campfire smoke long after the flames die out. Repressurization doesn't create these compounds from nothing. It simply releases them into air dense enough for your nose to finally detect what has been clinging invisibly to your gloves the entire time. Earth teaches every human being from early childhood that smell always signals something physically burning close by. Fire produces smoke, smoke carries particles, particles reach a nose, and a nose interprets those particles as danger, comfort, hunger, or memory, depending on context. That entire chain depends completely on oxygen-rich air surrounding a genuine combustion reaction happening in real time and space. Nothing about that chain applies to what happens inside your airlock after a spacewalk. No flame ignited anywhere near your suit, no fuel burned, no oxygen supported an actual fire capable of producing traditional smoke. Your brain still reaches for the closest available explanation anyway, translating unfamiliar chemistry into the nearest terrestrial memory it can locate. Welding fumes surface as one common comparison among astronauts describing this exact sensation after returning inside. Gunpowder residue surfaces as another alongside burnt almond cookies, hot brake pads, and ozone crackling after a summer storm. Each description differs slightly from astronaut to astronaut, yet every single one insists the underlying sensation feels unmistakably like something is actively on fire. Picture the sheer improbability stacked inside that single moment. Gloves fresh from vacuum now carrying a scent your brain associates with dinner gone catastrophically wrong. Material responsible for that smell formed inside a star that lived, aged, and violently died long before our own sun ever ignited from its own cloud of gas and dust. That star's final moments scattered carbon-based molecules across enormous stretches of space, seeding regions of the galaxy with compounds capable of surviving billions of years of drift. Some fraction of that ancient material, eventually settled into the cloud that formed our solar system, mixing directly into the raw ingredients that built planets, moons, and eventually spacecraft hulls. Decades later, an astronaut wearing a suit assembled from Earth-manufactured fabric drifts through open space, unknowingly collecting trace amounts of that same primordial material on every exposed surface. Returning inside pressurized air finally lets a human nose detect chemistry that began inside a dying star, translated instantly into a memory of walnuts, brake pads, or burnt toast. Smell here isn't stress, imagination, or a sensory glitch triggered by isolation and adrenaline. Scientists eventually confirmed this scent through direct chemical analysis, testing residue collected from returned spacesuits, tools, and exterior surfaces exposed during spacewalks. Laboratory results consistently identified the same polycyclic aromatic hydrocarbons responsible for the smell of grilled meat cooking over an open flame back on Earth. These compounds rank among the most abundant carbon-based molecules found anywhere across the observable universe, scattered through nebulae, comets, meteorites, and interstellar dust clouds. Meteorites recovered on Earth's surface routinely test positive for identical PAH compounds, confirming this material travels freely across enormous cosmic distances without breaking down. Comet flybys studied by orbiting spacecraft detected these same molecules embedded directly inside icy nuclei, hinting at their presence practically everywhere across the solar system's outer reaches. Every astronaut opening an airlock after months aboard the International Space Station effectively smells chemistry, connecting directly back to processes older than our entire planetary system. That epiphany reframes everything a curious mind assumes about where smell begins and where it ends. Humans have unknowingly encountered stardust through their own nose, long before anyone understood the astrophysics explaining why. Grilled meat, campfire smoke, and even the scent lingering after a lightning strike all trace back to chemistry involving the exact same carbon-based molecules drifting freely between stars. Recognizing that connection turns something as mundane as dinner on a summer evening into an unexpected echo of stellar death occurring billions of years earlier. Consider the distance those molecules traveled before ever reaching a human nose, crossing thousands of light-years of near-total emptiness before settling onto a spacecraft hull orbiting a small blue planet. That same chemistry born inside a collapsing star far beyond our galaxy's visible edge eventually ends up interpreted by a human brain as the unmistakable scent of a barbecue. Consider how strange it feels that ozone, gunpowder, and burnt almond cookies all describe the exact same underlying vacuum-borne chemistry, filtered entirely through memory rather than direct experience. Nobody aboard the station has ever smelled a dying star directly, since no human nose could survive anywhere near that kind of violence. Every description instead borrows familiar terrestrial references, translating alien molecular reactions into something recognizable enough to communicate clearly with mission control. That translation process reveals something profound about human perception itself, showing how thoroughly our senses depend on earthbound experience even when confronted with genuinely cosmic phenomena. Ozone formation happens in mere fractions of a second, once oxygen atoms clinging to suit fabric meet oxygen molecules flooding back into the airlock. PAHs release their scent more gradually, clinging stubbornly to fabric fibers until repeated exposure to fresh air finally lets that trapped chemistry escape completely. Both processes occur simultaneously during every single repressurization cycle, blending together into one complex layered scent no laboratory instrument on Earth had fully cataloged before spaceflight made it unavoidable. Your suit becomes, without any intention behind it, a tiny time capsule carrying material older than the sun itself. Every exposed surface collected trace amounts of interstellar material simply by existing outside your spacecraft's protective hull for a handful of hours. That material didn't announce itself, didn't glow, didn't behave differently from ordinary space dust drifting silently past your visor during the entire spacewalk. Only chemistry revealed its presence, waiting patiently until pressurized oxygen finally gave those molecules a medium capable of reaching a human nose. Nothing about that revelation required advanced instruments or specialized detectors, only the simple act of removing a helmet and breathing normally again inside a sealed airlock. Scale collapses entirely the moment you consider how far that carbon traveled before ending up clinging to a glove floating 400 kilometers above Earth's surface. Some fraction of those molecules formed inside a supernova explosion bright enough to briefly outshine an entire galaxy from certain angles. That explosion scattered material across distances measured in thousands of light-years, material that continued drifting silently through the void for spans of time longer than our entire solar system has existed. Eventually, gravity gathered enough of that ancient material together to form the very cloud that later collapsed into our sun, our planets, and every living thing that has ever existed on Earth's surface. Meanwhile, that same category of molecule kept drifting freely through space independently, some portion of it settling directly onto a spacecraft hull built by descendants of that original stellar material now returning to space themselves. Earth's kitchens and airlocks orbiting hundreds of kilometers overhead share an identical chemical signature connected by carbon compounds indifferent to whether they end up in a backyard grill or drifting silently past the orbit of Jupiter. That connection reframes something as simple as a burnt smell into direct physical evidence of humanity's stellar origins. Every carbon atom inside your own body once existed inside a star, exactly like the ones responsible for scattering these molecules across the galaxy in the first place. Detecting that scent after a spacewalk isn't a curiosity limited to astronauts alone. It's a sensory encounter with the same raw material that eventually became bone, blood, and breath. The smell that clings to an astronaut's glove is not an artifact of human imagination. It is a direct chemical message from the depths of stars that lived and died long before our own sun ignited. Every time we detect that burnt metallic scent, we are in a very real sense smelling the raw material the universe used to eventually build us. Future missions venturing beyond low Earth orbit will likely encounter even richer concentrations of this ancient chemistry drifting freely through regions of space untouched by any previous human visit. Crewed missions returning from the Moon during the Apollo program already reported nearly identical scents clinging to lunar dust carried back inside their spacecraft, describing it as spent gunpowder settling across every surface it touched. Mars-bound astronauts will likely open their own airlock someday and encounter chemistry shaped by an entirely different planetary history, carrying scents no human nose has ever previously cataloged. Each new destination promises fresh variations on this same underlying mystery chemistry, translated instantly into memory alien reactions filtered through distinctly human senses shaped entirely by one small blue planet. Somewhere beyond the next airlock, another scent waits patiently carrying its own quiet message from somewhere deep inside the universe's long, unfinished story of stars living, dying, and scattering the raw material for everything that follows.